You guys.
Step, curry. Step on.
Hurry up.
Whoa.
Can I go please get some water?
Hurry up. You guys have the worst timing.
Well, that's not even started yet.
You think?
Why is that the snow after melt?
So Luis is sick.
Yeah, he's not been feeling it.
I don't know if the water bottle.
Do you see her last week? He was depressed.
He was sleeping for the past
Because it's
2 days.
empty, that's
Do you
why.
see that I'm in first hour?
Hurry up.
Hurry up.
All right, sit your butts.
Water bottle.
Sit your butts.
Oh, he left
No,
early?
it's not, you have your, is this Nolan's?
He was in
No,
first.
probably. That looks like a Nolan water bottle.
It doesn't.
Andy filled his water bottle.
What's that supposed to be?
Something a water bottle.
Okay, I gotta get you guys to know.
2 pages, man.
What else did we talk about? Something like off-brand.
You said we're not prepared.
What is
So you're gonna have the notes.
Oh, I tried.
Kick him out.
Nathan, we'll get out early, right?
No, without.
Oh,
You.
actually, I think we do.
Oh,
You gotta get out, it's too hot in here, man.
What did I do?
You saw that email, right, Miss Lawton?
You're so
What's that?
toxic.
The football players, it's, 1:55, we're supposed to eat this.
Okay.
Such a bull.
2:15 tomorrow, actually, though, by the way.
What is this?
Hey, Miss Botton,
This last one.
I might get
Why does
this.
it have 2 pages?
I have,
Everybody
knows now.
You might get to this
Yeah, yeah, yeah.
I will. I'll spread it.
No, I'll take you, we can both.
for.
You are still drinking your
I'll handle
What's your number?
3-6, dog.
All right, we are getting started. So if you don't want to sit in your seat, go to the office.
Did Owen get sent to the office?
I'm right here, Caleb.
Guys, we need to focus today and lock in. Lock in. Go. Hashtag
You got 1 extra, boss.
Hashtag grow.
Oh, man.
And that said 117.
My notebook. Why'd you steal my notebook?
Okay,
Bottom,
so today we are learning something new.
where do you want this?
I think Botton, they should take us three and put them in your morning crew. Then we're still sleeping. We're not fully awake. And
I don't
we're not
have those
sick and tired of sitting all day.
Okay, so we are gonna get started. What we are going to do today is learn kind of the different angles that you can have in trig, and we're gonna lead into something called the unit circle. And when you guys take trig next year, you will get very, very familiar with what's called the unit circle, okay?
What if we're not?
So-
Only a few of us
Are taking trig next year.
I think only a few.
I never.
I'm taking Trey Gill.
What?
You taking Trey?
So
No, I'm
anyway,
not taking Trey.
so listen up. So when you look at this, what you have is this side, they just kind of came up with this axis like this. This is 0 degrees. Up here is 90 degrees. Over here is 180. And this is 270. And then back here again would be 360, which would be a whole rotation, okay? Then what's gonna happen today is you're gonna have angles that are drawn on here. And this is always what's called your initial side or the beginning part of your angle. And then this right here probably looks like it's about a 210 degree angle. So it starts here, it goes to here, which would be 180. And then it would have to go further than that. And notice 270 is down here. So this would be about 30 degrees. 180 plus 30 is 210. This side right here is said to be what's called a terminal side, okay? So when we draw these angles, again, this is 0 degrees, this is 90, this is 180, this is 270, and then this is back to 360. If they asked you to draw a 120 degree angle, obviously it's gonna be between 90 and 180, okay? So what you would do is draw to 90 and you would have to get 30 more degrees, okay? So this would be a 120-degree angle right here, okay? Yes,
Do we need a protractor for this?
no, you're just estimating, okay?
Why'd I buy one?
Now, now, when you have a negative angle, stop you guys. When you have a negative angle, you go in the opposite direction. So if it's positive, you go in the, what would this be, counterclockwise direction. If it's negative, you start on that initial side, but you go in the clockwise direction. So if they told you to draw a negative 145-degree angle, if you're doing it clockwise, this is negative 90 degrees. This would be negative 180 degrees. This would be negative 270 degrees. And then this would be negative 360 degrees.
What if it's 810 degrees?
We'll talk about that. So this negative 145 would be in between these two. And then you just kind of estimate. If this is 90, do you get that this one would be 55 right here? So you're kind of estimating if this is a total of 90, where would 55 degrees? Just kind of an estimate, okay? So here they're asking us to draw a 300-degree angle. You always start where this is your initial side, okay? If you're going 300 degrees and it's positive, you're starting here and going in this direction, okay? This is 90, bless you, this is 180, this is 270, and if I'm going to 300, did I get into you yesterday?
Yeah, I know, isn't it great? There's all the results, and then this is the result.
To get in? Oh, yeah, you're fine.
Yeah.
Yeah, you're fine. Okay, so if it's 300 degrees, you guys, it's gonna be over 270, right? But less than 360. And do you guys get that it would be about 30 degrees over here?
Yep.
So it's about like this. That would be a 300-degree angle, okay? Caleb, stop. No, no, not, you don't have to. You just use that as an estimate. Caleb, sit there. Now we have 215. If it's positive, you start, you don't really have to draw this, but this is your initial side, okay? 215, if it's positive, you're going here. Do you guys get that 215 is going to end up in this quadrant? And what's 215 minus 180? That's 45. So I probably drew this a little bit too far. So your 35-degree angle might be something like this. So that would be 215 degrees, okay? Then if you're doing negative 40, we always start here. Do you guys get that negative 40 is going to be in this quadrant here? And if it's 40, maybe it's something like this. Get that? Okay. This one is negative 150. So again, when you're doing negative, this is 0. This is actually negative 90. This is actually negative 180. This is actually negative 270. And this is negative 360. So if I'm doing negative 150, so you get that it's going to be in this quadrant right here. And if it's 150, wouldn't 150 from 90 to 150 be 60 degrees? So it's going to be about like that. Well, maybe a little bit more up. This more looks like a 45, but
That's all I had in mind, Doc.
that's it.
No, you don't have to get it close.
Okay. Everybody understand that? Okay. Now if I go here, this is kind of what Caleb was just asking. What if your angle that you're doing is bigger than 360 degrees? What happens is you can have more than one rotation that you do around it. So a full rotation is 300. Shh. So when you're doing 390 kilos, seriously, okay? If you can't handle it, go home. So if it's 390, do you guys get that a full rotation is 360?
Yeah.
And then how much more would I have to do to get to 390? Just 30, right? So it looks something like that. So you actually draw the little, you know, the whole time around, because sometimes you might have 2 times around and you have to draw that too, okay? So if I did a positive 495, would I do a whole time around? So I'm gonna do a whole time around, and that's 360. Now, if you're thinking, what would I have left? 495 minus 360 is 135, okay? So what I would do, 135 is halfway between 90 and 180. So I would go to here, and that is my line. But this is important. You actually have to draw this, showing how many times around it goes, okay? Now this one is negative 420. So remember, this is 0. If it's negative, this is negative 90, negative 180, negative 270, negative 360, and so on. If I'm doing negative 420, do you guys get that I would go around like this once to get negative 360? And then how much more is left over if I have to get to 420? Like 420 minus 360 is 60. So I'd end about right here, and that would be my line. Okay. Now I have negative 560, and I'm going to add 360 to that to see, wouldn't I just need 200? Okay. So again, this is negative 90, this is negative 180, this is negative 270, negative 360. So for sure, I go around once, and that's negative 360. Now I need to go another 200 degrees. Where would I end up? If you think of quadrants, this is 1, 2, 3, 4. What quadrant would I end up in? This one, right? You guys get that? This would be another 180, and then I have to get to 200. So wouldn't I go just a little bit above that? And that would be 200. You guys understand that?
Yep.
Then I have 810, okay? So 810 minus 360, which you can do this on your calculator, you do not have to show this. It's gonna be 450, okay? So don't I have to go 2 times around? And 450 minus that is 90. So what I would do, this one's positive, so I go once around, twice around, and then I have to get to 90. So do you guys get it? Would be end up right there, and then I just, this is my angle. Okay. All right. Now let's go here, and we're going to learn about something called coterminal angles. Okay. So there are certain angles in trig that are really the same angle, and it would be like, for instance, if you took any angle and you added 360 to it, the angle that you get is going to look just like 60, okay? You're going to have that little rotation thing, but you're going to end up at 60 no matter what. If I added 360 to the 420, it would actually be 780, but all that would be is another rotation on this, but my overall terminal side, it's called, is gonna be in the same spot. So you could keep adding 360, and all of those are called terminal angles. Just like if you took it and subtracted 360, if I did 60 minus 360, I'd start here, I'd go to this is 180, this is negative 270, this right here is negative 300, and again, I end up at that same point. So if you take an angle and you add 360 to it or subtract 360 from it, you're going to end up with the same terminal side, okay? They are called coterminal angles. And how you find them, we don't know about the 2 pi yet, but what you would do is keep adding or subtracting 360 to that angle. So you're going to have some problems today that are going to ask you to find an angle with a positive measure and a negative measure that's coterminal with this. So if I'm trying to find a positive one, okay, what I would do is take 130 and add 360 to it, which is 490. That would be coterminal with that 130. If I graphed 130 and 490, both of them would have that same terminal side. Now, I could add 360 to this again and get a different coterminal angle. That would still work, but typically I just do the smallest coterminal, okay? Then if I go to find the negative one, you take your angle and you subtract 360 until you get to a negative angle. And 130 minus 360 is negative 230. If I graphed 130 on that coordinate axis and a 490 degree angle and a negative 230 degree angle, they all end up with the same terminal side. Yep. No, you mean like this? No, you can just type it into your calculator, it's fine. So now here, if I'm trying to do my positive, okay, I take negative 260 and add 360, and I get 100 degrees. If you added 360 and it was still negative, you would have to add 360 until you get a positive angle, okay? So if this had said negative 100 and you were to a positive angle again, just add 360 again. When I go to do a negative one, I can't use that negative 260 because that's our actual angle. So I take negative 260 and I subtract 360 from it. And that would be negative 620. Okay? So again, you would want to have one that's positive, one that's negative. I could have different answers, like I could add 360 to this, I could subtract 360 from this, but I typically just stop at the smallest negative and the smallest positive. So now, if we go to this page, do you guys remember back when we did, like at the end of last week, or was it just yesterday? It was just the last 2 days. Do you remember how we went into mode and we wanted our calculator set on degree? But one of the things that you have to worry about when you're doing trig is you have 2 different types of angles. You have angles that are in degrees and you have angles that are in radians, okay? For now, we're going to keep our calculators on degree, but we will be switching them possibly. Yes. You're not. All right, so if we look at this, what we're doing is learning what is a radian. Okay, why do they talk about radians? So this isn't super important, but a radian, what it is it is going to be the measure of the central angle when the arc length is the same as the radius. So when this distance is the same as this, okay, that's when you have 1 radian measure, okay? You don't have to worry about that, but what you do need to know is that pi, which we'll look at, is equal to 180 degrees. 2 pi is equal to 360 degrees, okay? So if we now start talking about graphing with radians, this is 0, this is pi, this is pi divided by 2, because this is like 180, this would be half of that, so it's pi divided by 2. Down here at 270, okay, that is going to be 3 pi over 2, and you do not have to memorize this, okay? That will be something you'll have on your cheat sheet. And then if you do a complete circle here, 360 degrees is 2 pi. So you're gonna just get to know these as you use them, and this is kind of the setup of what your unit circle will look like. So if I go down here, one of the questions that they're asking us to do is take an angle that's in degrees and change it to radians, and take an angle, when you see an angle that has a pi in it, that means it's a gradient, okay? If you see a degree symbol, that means it's in degrees. And this should be on your cheat sheet. Did I give you guys a cheat sheet at the beginning of this? Does somebody want to take that out so I can make sure this is on it? You might have been off. Okay. So when we go to change from degrees to radians, it tells you what to do. You have to multiply by pi over 180. Okay? So if I'm changing from degrees to radians, I multiply by pi over 180. So I take negative 30 times pi over 180. Now, with that 30 and 80, you reduce it. It's like it's a fraction. It's like this is negative 30 pi over 180. And if you have a graphing calculator, do you know that you can go negative 30 divided by 180? And then to reduce that, if you don't want to do it in your head, you can go math, enter, enter, and it'll reduce it for you, okay? So if we go back to our notes, do you guys get 30 goes into each of these? So it's negative, 30 goes into 30 once, so I'm just gonna have my pi on top, and 30 goes into 186 times. When we did that calculator, it reduced to negative 1/6. So this is like negative 1/6. This is your answer in radians that's equal to negative 30 degrees. Which part? Oh, yeah. So I put it in as a division problem, and then I went math, and I hit enter twice. Okay. So if we go back here, the next kind is asking us to take this. This is in radians, and how I know that is because it has a pi, okay? And up here, it's telling me if it's in radians and I want to change it to degrees, I multiply by 180 over pi. So I would take 5 pi over 2, and I would multiply by 180 over pi. All right? When I do this, my pi's cancel. How many times does 2 go into 180? 90. So if you wanted to, you could do that. And then do you get you're left with 5 times 90, which is 450. Okay? Another way you could have done that, if you didn't want to think like that and you just wanted to go to your calculator, you could take 5 halves times 180 and have it reduce it. So let me show you that. You could go parentheses, 5 divided by 2 parentheses, 180, and whoops, and that'll know to multiply, or you could go times 180. And you can hit enter, but we want our answers in fractions. We don't want them any decimals with this at all. So if I go math, enter, enter, it gives it to me. If it was something that was going to be a decimal, that would just do that for you, and it would be something like 9/2 or something like that. Okay? So that one is 450 degrees. So this is radians, this is degrees. Now this one is already in degrees. So up here, if you're changing from degrees to radians, you multiply by pi over 180. So I'm going to go 330 times pi over 180. Okay, if you didn't have a calculator, doesn't 10 go into each of these? 10 goes in here 33 times, 10 goes in here 18 times. Okay, so what we would have left on top is 33 pi, and on the bottom I'd have 18. Do you think we can reduce 33 over 18?
11 and 6.
Oh, yeah. Sorry, I didn't even think I could. Yes, 11 pi over 6. But again, if you wanted to just go 330 divided by 180, math, enter, enter, it'll do it for you. Okay? All right, last one here. We have a radian measure. I can tell that because of the pi. So I'm going to multiply it by 180 over pi. So I have negative 3 pi over 8 times 180 over pi. So my pi's cancel. Now, as far as I could think of what goes into 8 that also goes in here. Well, I know that 2 goes into 8 4 times, 2 goes in here 90 times. And then I'd have on top negative 3 times 90 is negative 270 over 4. And does 4 go in there?
Yeah.
Negative 60. What is it? 67.5. And we really, with degrees, it would be okay to do that. But if it was something like with a pi, so say there was a pi in this, okay, they don't want you to have decimals at all with a pi. So then what you would want to do is go to your, if you don't want to reduce it, then your head, you go negative 270 divided by 180. Is that what it was? No, that's not what it was.
4.
What was it?
4.
Divided by 4?
Yep, it should be 135 over 2.
Oh, that gave me a decimal.
Yeah.
Because I didn't do math enter. Negative 270 divided by 4, math enter. Negative 135 over 2. So if it's something with pi, you want to leave it.
Why could you just do 4 instead of 1?
Because I should have done that. I just didn't do it. We're not all perfect.
I know.
All right, so let's go here. So this, we have 2 things left. This is where you're, just like we were doing the previous problems, where we were finding a positive measure and a negative angle that was coterminal with this. And before, what we did is we added or subtracted 360 degrees, which is a complete revolution. Now what we're going to do is add or subtract 2 pi, okay? So for your positive angle, you would go 2 pi over 3 plus 2 pi. Now, this is kind of a pain because of the fact that you have to get it as a fraction, okay? So if you did that by hand, like back what you guys learned when you added fractions, do you remember how you have to get this over 3, and to change the bottom, you'd also have to multiply the top by 3? Do you get that? Okay, so this would be 2 pi over 3 plus 6 pi over 3. And then you would just add that. You'd have it over 3, and what's 2 pi plus 6 pi? 8 pi. And then you should check, can you reduce 8 over 3? And you can't. So that is your answer. Now, I believe if we went to our calculator, we could have gotten that 8/3. So let's do that. Let's do 2/3 plus, in parentheses, plus 2. So that's basically what we were doing. It's 2/3 pi plus 2 pi. And then if you went math, enter, enter, it gives you the 8/3. So you could use your calculator on there if you wanted to. Then what you're going to do to get the negative angle is you're going to do 2 pi over 3 minus 2 pi. Which again, if you do it by hand, you're going to multiply by 3 on top and bottom to get it to the same thing. So it's 2 pi over 3 minus 6 pi over 3, which is negative 4 pi over 3. Okay. Then, if we look at this next one here, this right here is negative 3 pi over 4. So the first thing I would do is take that negative 3 pi over 4 and add 2 pi. And again, if you're doing this by hand, not using a calculator, you'd want to multiply the top by 4 and put it over 4. So then what you would have is negative 3 pi over 4 plus 8 pi over 4, which is what? 5 pi over 4. So that would be your positive angle, okay? Then when you do your negative angle, you would take the original. And we already know now that what we're adding and subtracting over 4 is 8 pi over 4. So we could just subtract 8 pi over 4, which would be what? Negative 11 pi over 4. You don't want to do those as decimals, okay? Now C happens to be one where when I go to do the positive, okay, I can add 2 pi to it. And if I wanted to do it without my calculator, I'd multiply this by 5 and I'd put it over 5. So it would be 11 pi over 5 plus 10 pi over 5, okay? Do you get that that would be 21 pi over 5? And that would be a positive angle. Now when I go to do the negative angle, 11 pi over 5 minus 2 pi, and 2 pi in this case is going to be 10 pi over 5. So if I subtract 10 pi over 5, I get pi over 5. This was supposed to be a positive angle. This was supposed to be a negative angle. But is this a negative angle? No. So then what you would have to do is subtract 10 pi over 5 again. And 1 pi over 5 minus 10 pi over 5 is negative 9 pi over 5. Okay? Then we have one last thing. It's not very hard. So this I'll just show you. This is the unit circle. This is what it looks like. Inside it has the degrees, outside it has the radian measures that it's equal to. And then there will be things that we add on to this. That will be, it'll tell us what's the cosine, what's the sine, and what's the tangent at every single angle, okay? Notice this is 0, this is 90, halfway in between is 45, which is pi over 4. You'll get to know that. At pi, it's 180. Halfway between there is 3 pi over 4, which is 135. Halfway between here is 225, or 5 pi over 4. 270 is 3 pi over 2. Halfway here is 315, which is 7 pi over 4. And then back here is 2 pi. Okay? It's important too that you know that this is the first quadrant, this is the second quadrant, this is the third, and this is the fourth. And then the last thing that we're going to do today is they're going to have us find arc lengths in a circle using this formula right here. It's not very hard. They're going to give you a radius and the central angle. And all you're going to do is multiply them. But here's the key. To do this, your angle has to be in radians, which it should be, okay? So if I look here, this is what this problem will look like. To find the arc length, I take the radian, or the radius times the central angle. So all I would do there is I go 3.5 times pi over 2. Now this is different. When you're finding the arc length, you actually multiply this out on your calculator, and you actually use the pi key. So you would go 3.5 times your pi key divided by 2. So if we do that, we'd go 3.5 times the pi key is above this. So we'd go second this for pi, and then it was divided by 2. Thank you. No one? They want you to use your pi key just so everybody has the same.
Well, yeah, essentially 3.5 or 20.
Oh, I see what you're saying. 3.5 parentheses pi divided by 2 parentheses, like that?
Yeah.
Yes. That would maybe that does make more sense. So that's 5 point, and we're going to round to the second decimal, the hundredth. So wouldn't that actually be 5.50?
Mm-hmm.
Okay. So this is 5.50. Now here, our radius is 3, and here we have 7 pi over 6. So that might be easier the way Nolan was saying. We can go 3 parentheses, 7, second, this up arrow, take your pi divided by 6, and it's 10.1. That actually rounded up to 11. And then the last one would go 4 pi, or 3 times 4 pi over 3. What happens to those 3's? They cancel. So you'd actually just have 4 times pi there. 4 times second pi, 12.57.
Mm-hmm.
Okay, so your assignment then.
32.
Oh, that's pretty
Oh my God.
Wow.
I think you're seeing it right.
I think I need
That's like those slices.
That's as many points as St. Olaf scored last night.
And then I did this to
Oh, sure.
because I didn't really know how much time we had because we had a while. So I was like,
Man, he does.
So I mean, might as well just come here so I don't have to watch the video.
Yeah,
So
I agree. Yeah, no
I'll
problem.
just come in.
Yeah, for
No,
sure.
I'll be late.
Nope, nope, just write absent though.
Can I go in there?
Oh, don't worry about it.
You got her?
a timer.
Perfect. Yeah,
I trust you, Pete.
Can I go get my book?
yes.
Oh, no worries, I got you.
I got one too.
Yes, right there.